Alright, we're going to go ahead and get started with Unit 5, which covers the topic thermodynamics. Thermodynamics is a fairly challenging topic for many students, but it is an extremely important topic and one that is usually heavily tested on an AP or an IB exam. The idea behind these videos on thermodynamics is just to get you started with a basic understanding, background information about thermodynamics, and then in class we will do some labs as well as go through some more complicated type of thermodynamic problems. The first lecture that we're going to look at today is energy. And energy is a very important basic topic within thermodynamics to get us started with understanding that topic. We need to understand what energy is, the laws that are associated with energy, and some of the basic principles behind energy and chemical reactions. So before class, make sure that you understand these essential questions for this topic. These are the essential questions that will be looked at or examined by in our quiz that we take in class. So by the time you're done with this lecture, you should be able to understand and answer these essential questions. First of all, what is the first law of thermodynamics? If you already know that, that's great. If you don't, you're going to learn that here. The second question is, what is the difference between endo and exothermic processes? So let's start out with looking at a definition of what energy is. Some basic ideas of energy is known as the capacity to do work. Or to transfer heat. Alright, so that's kind of our basic definition of energy. The capacity to do work or to transfer heat. There are two types of energy that you need to be familiar with. Most of you already know these. One is kinetic energy, and kinetic energy is the energy of motion, or when an object is in motion, it has kinetic energy. The other one is potential energy. Potential energy is stored energy, or energy that can be used for work later on. And it's usually tied up in chemistry into chemical bonds, which we'll discuss a little bit later. Alright, so what are the units of energy? Well, in chemistry, we're going to go ahead and use what is known as the joule of energy. And basically, 1 joule of energy is equivalent or equal to 1 kilogram meter squared per second squared is the unit of a joule. We also use what is called the calorie. A calorie is equivalent, so 1 calorie is equal to 4.0 184 joules. Alright, so again, 1 calorie is equivalent to 4.184 joules. What is a calorie? Well, essentially a calorie is the amount of energy required to raise the temperature of 1 gram of water by 1 degree C. Okay, let me repeat that. A calorie is the amount of energy required to raise the temperature of 1 gram of water by 1 degree C. Alright, so these are the units of energy that we're going to deal with in this class, the joule and the calorie, mainly the joule, so become familiar with them. Alright, so next we're going to look at this essential question of what is the law of conservation of energy? Well, just like in the law of conservation of matter or mass, that mass is conserved during a chemical process, well, energy is also conserved during a chemical process. So let's just simply say that during a chemical reaction or a chemical process, energy is conserved. We do not gain energy, we do not lose energy during a chemical process whatsoever. Alright, so that leads us to this idea then, along with the law of conservation of energy, energy can, though, even though it's conserved, energy can be transferred. Can be transferred from one form to another form. Oops. Form of energy. So essentially, even though energy is conserved, we can transfer energy from one form to another, such as moving from mechanical energy to, say, chemical energy, or chemical energy into mechanical energy. So it just transfers back and forth. We have a special name for the law of conservation of energy when it comes to thermodynamics. And in thermodynamics, we call this the first law of thermodynamics. So the first law of thermodynamics simply means that energy is conserved. So it goes right along with the law of conservation of energy. So the first law, which all you need to know, the first law of thermodynamics, is indeed another name for the law of conservation of energy, where energy is conserved. Alright, so now let's get into eternal energy a little bit. Internal energy is basically the total amount of energy that a chemical reaction or process is going to have. The total amount of energy that an atom has. Total amount of energy that a molecule has. And so the internal energy is essentially made up of two things. Essentially made up of two parts. Kinetic energy. So all the kinetic energy that a reaction has, and all of its potential energy. Okay? So, again, the total amount of kinetic and potential energy combined together for any system, for any chemical process, for any molecule, atom, whatever, that is the total internal energy. All right? Now, kinetic energy we talked about was the motion of molecules. So we can box this and we'll say the motion of molecules. So because molecules have motion, they have kinetic energy. Now there are several types of motion of molecules. We can have rotation. So molecules can be rotating. So rotations, as well as vibrations. As well as moving in straight line paths. So molecules are always in motion and they have kinetic energy. Now the potential energy of the system is stored energy, and that stored energy is found within bonds. So that basically that is stored in chemical bonds. All right. So basically, when we're looking at reaction systems that made up of two types of energy: kinetic energy, which deals with the motion of the molecules, and potential energy, which is the energy that is stored in the chemical bonds of molecules or bonds between molecules. Sometimes we will refer to potential energy as chemical energy. So write that down. Potential energy is often known as chemical energy. Alright, so now what we're going to do, now we understand a little bit more about potential and kinetic energy and internal energy, we're going to look at the differences between heat and temperature. Now, heat is often sometimes misunderstood, so we're going to try to take a little bit of time to understand this a little bit more. So, really, heat is energy. Okay, heat is energy that is really transferred heat is energy that's transferred from a hot object to a colder one. So essentially we can look at heat is really energy that's been transferred, or transferred energy, from one object to another due to differences in their hot and coldness, or temperature differences. So we can also look at this in another way then, is the energy transferred between a system and its surroundings. Because of the difference in temperature. All right. So again, heat energy is energy that's being transferred from one object to another because of differences in temperature, or what we would say moving from a system and or the difference in temperature between the system and the surrounding. The surrounding is the surrounding environment, where the system is what we're being focused on. In chemistry, usually the system is a chemical reaction or a chemical process. And so whatever we're focusing on, that is the system, and everything else is the surrounding environment. All right? I'm going to erase this, and let me kind of illustrate this in a diagram. Okay, so let me diagram this. Let's say we have a system. And remember, the system could be a chemical reaction, whatever. But let's just say that this is a system, and the system is at 50 degrees C. And that means everything outside of the system is known as the surroundings. Let me rewrite that. The surroundings. And let's say that the surroundings has a temperature of 25 degrees C. Alright? Well, if the system is 50 degrees C and the surroundings is 25 degrees C, since there are different temperatures, there's going to be a transfer of energy. And the transfer of energy is always going to move from a hot object to a cold object. Now, this is very important. So let me repeat that again. Because there are differences in temperature, there's going to be a transfer of energy. And that transfer of energy is always going to move from a hot system to a colder environment. And so in this case, because the system is 50 degrees C, which is a higher temperature than the surroundings at 25 degrees C, energy is going to be transferred to the surrounding environment. And that transfer of energy is known as heat energy. So heat energy is going to move from the system to the surroundings, in this case because the surroundings has a lower temperature than the system. Now, we are going to abbreviate heat energy and give it a Q. Q is the symbol for heat energy. And because the system is losing heat energy because it's being transferred, we're going to give the system a negative sign of Q. And the negative sign just means that the system is losing energy. The surroundings, because it's gaining energy, is going to be a positive Q. The positive just simply means that it's gaining energy. The negative simply means that it's losing energy. And so make sure you understand the sign usage here. It's very important. All right? So, what is temperature then? Temperature can be looked at as a measurement. Okay? It measures the hotness or coldness of an object and determines the direction of heat flow. So when we say that again, temperature is a measure of hotness or coldness of an object and determines the direction of heat flow. When heat is transferred to the surroundings, Q is negative, and when the system absorbs heat, Q is positive. And so make sure you're aware of those ideas. Alright, so now we're going to look at our last big idea here, and that is, what is the difference between an exothermic and an endothermic reaction? Well, to look at this, it is simply this. When a chemical reaction transfers heat to the surroundings, the process is exothermic. Let me say that again and write this down. When a chemical reaction transfers heat to the surroundings, the process is exothermic. But when heat is absorbed by the chemical reaction or the system from the surrounding environment, the process is endothermic. So let's just look at that in simple terms. If the system releases energy, it's exothermic. But if the system absorbs energy from the surroundings, then it's endothermic. All right? So those are two important ideas. Now let's diagram these ideas using a graph. And these are called energy diagrams. And you need to become very familiar with energy diagrams. Make sure you know them, be able to draw them, and recognize them. So let's draw one energy diagram here. On our y-axis, we're going to put potential energy. And we're going to go ahead and actually, I like how this is turning out, this graph. Let me make it a little bit bigger. There we go. So potential energy there, and then we're going to draw the graph here. Looks like this, okay? So our reactants are going to be up here on our graph. And they're going to be at high potential energy. And our products are going to be at lower potential energy. The idea here is that during the course of the reaction, the reactants are going to lose potential energy. But energy is conserved, and so the potential energy that the reactant molecules lose can't be destroyed or lost forever. Instead, what happens is the potential energy is converted into another form of energy. And in this case, that is heat energy. So really what we're looking at is the difference between the reactants and product is heat energy, or Q. And since the reactants are losing energy, the sign for Q is going to be negative because heat energy is being transferred. So we could say that heat energy is transferred. From where? Well, it's transferred from the system, which is the chemical reaction here, to the surrounding environment. So heat is being lost by the reaction, and therefore that we get the negative Q. So the difference in energy between the reactants and product is just simply that the potential energy from the reactants has been changed to heat energy, which has been transferred to the surrounding environment, and so the products are lower. So what kind of reaction is this? Well, this is an exothermic process, and this is what the graph indicates is an exothermic reaction. So make sure you understand that. In an exothermic reaction, heat is just being transferred from the system to the surrounding environment. Alright, so what about a different situation where, when we rewrite this graph here, we look at another graph, and so we looked at an exothermic. Well, what about an endothermic? Okay, well, an endothermic is simply going to be almost the opposite, where we start out with the reactants at low potential energy, and the products at higher potential energy. Well, how did this happen? Well, obviously the reactants had to absorb some energy and transfer it into potential energy. So the products have more potential energy. Well, that means that the difference in energy here has to be the fact that energy was transferred from the surroundings to the reaction. Therefore, we're looking at a transfer of heat, or a positive Q, from the surroundings to the reaction. So this is an endothermic reaction, where simply that energy, or heat energy, instead of being transferred to the system or surroundings, it's being absorbed. Okay, by the system or the chemical reaction. So to make this simple, just think of the fact that if it's an endothermic reaction, an endothermic process, heat energy is always being absorbed by the reaction. It's always moving from the surroundings to the chemical reaction, where the heat energy is going to have a positive sign because it's absorbing energy. The reactants are always in lower potential energy. The products are always in higher potential energy when this occurs. Alright, so these are the ideas between endo and exothermic. I would strongly suggest that you relook at this idea, the differences between endo and exothermic. They're very important. So it comes back to our idea of, let us look at our essential questions. Do we understand what the first law of thermodynamics states? And again, that simply states that energy is conserved during a chemical reaction. Now, can energy be transferred from one form to another? Absolutely, but it is conserved. We also need to understand that heat energy is transferred energy from one object to another, and energy will always be transferred from a hot object to a colder object. And then let's look at the difference between endo and exothermic. An endothermic reaction is one in which heat energy is transferred from the system to the surroundings, whereas an endothermic reaction is heat is absorbed from the surroundings to the system or to the chemical reaction. Alright, so that is it for this particular lecture. Again, review your notes, be ready for a quiz, review the video as often as you need to, come to class with questions that we can answer and so forth. And so that is it for now.